So in the past couple of classes, we looked at using some graphs, and we talked about some trigonometric functions. And so now we're going to look at yet another option, and that is to simplify before. And if you don't have a calculator, you may want to on a calculator just points here, in particular about the difference between a limit when you plug in and get 0 over 0 as opposed to when you plug in and get some number over 0. Okay, but you can see what I have written up here already, right? It's just that the third thing you can do whenever you get, for instance, in this example right here, plug in a 2. If we just immediately tried to plug in, we would have 2 minus 2 over 2 minus 2, which is 0 over 0, and that's a problem, and you'd want to say the limit does not exist, but in reality, that's not true. And x minus 2 divided by x minus 2 is just 1, right? So all I've done is I've simplified the problem. I can cancel the top. Function is always 1. So there's your answer. So you can always simplify before you begin. Now let me jump here. X. What's our first option? Plug in. Don't lose sight. I'm going to try to plug in. 5 plus negative 5 squared minus 25 all over negative 5. Right. 0. And 0 squared is going to make, so this is 0 minus 25 divided by negative 5. Nice and easy, right? Your first option is to go there. Sure. There you go. All right, so the first thing we're going to try is, plugging in. So I'm going to pick 3, and 3 is the number that we're trying to take the limit. So I'm going to plug it in over 3 squared minus 5. See what I can come up with. 8 times 3, 4. Okay, we're just going to keep working this thing. 9 gives us 45 minus, and I'm going to go ahead and combine these since they're both negatives, and so this will give us negative 37. And then 9 minus 5 is 4. So, yeah, 45 minus is 8 over 4. So this one's 2. Absolutely, you want to try to plug in. So here we go. We're going to plug in, and what's going to happen is going to be 3 times 2 squared minus 2 minus 10 over 2 squared 4. Trouble, right? Because this will be 3 times 4 when you square the 2. That right there is going to make, if I combine the negative 2 and the negative 10, it's going to make negative 12. And then on bottom, 2 squared is 4 minus 4. Right? Now, when you have a 0 on bottom, you don't abandon it, right? There's put in. And so what we want to okay, we want to try to simplify before we get started. Okay. Simplify before from the start. So, looking at this right here, the limit as x approaches 2 of this function, what we want to try to do is we want to try to factor this function in some way. And so hopefully you guys factor, right? I'm going to keep my limit because I can't plug in yet. So I'm going to write my limit. But now I want to try to factor. Yeah, I'm going to factor it into 2 sets of parentheses. And this right here would be 3x and x. That's what would give me x squared, right? We got to go through how to do that. These should multiply together. They should combine to give me that number, right? Now, the last 2 numbers multiply together in order to give us 10, okay? And then the result from the multiplication of the last numbers and the first numbers need to add together and give us the middle number, okay? So hopefully you remember most of that from Algebra 1, and that's not, overly confusing for you. But I want to put minus 2 plus 5. And that, you're like, how did you get that? Well, it's just a lot of it out. Now, this is what I'm looking at. The negative 2 and the positive 5 right there would multiply together to give me this negative 10, right? And then I know from doing the FOIL method a lot that what I'm going to have to do is this negative 2 is going to get multiplied by that front number over there. And the negative 2 and the positive 3x is going to give me a negative 6 when I multiply them. 5 is going to get multiplied by the x right there, so that's going to make a positive 5x. And what happens is when I combine those 2 numbers, I need to get whatever's in the middle right there. And you can see that negative 6x plus 5x will give us negative x. This is a difference of squares, right? So with the difference of squares, when you have, this is, so this changes into x minus 2, not squared, sorry, just the x, right? X minus 2, x plus 2. Right, and so now, there's nothing but multiplication going on here. And so I have an x minus 2 on top and an x minus 2 on bottom. So I can cancel those two out. And so now what's going to happen is this thing is going to change into the limit as x approaches 2 of 3x plus 5 over x plus 2. So now that So now let me try to plug in 3 times 2 plus 5 over 2 plus 2. Well, 3 times 2 is 6 plus 5 makes 11, and 2 plus 2 makes 4. That's the final answer. Yeah. Of the two different things that can happen. When do you analyze and when do you use algebra? Okay, that's the question that we're looking at right here. When do you do which one? Let me make this a little bigger for some of you in the back, if I can get it all together. Here we go. One more try. Okay, so the difference between when you should analyze and when you should use algebra. Okay, if you look at this first, one exception to that rule might be the absolute value of x over x. Again, we talk, if I plug it in, then 8, I would have a really small positive, and if I plug that in, 1 divided by a really small positive would give me a positive infinity. And so you would think, oh, well, negative infinity on one side and a positive infinity. For just a second. Let me give you a function. Let's say, well, let's just take this function that we have right here. So I'm going to go into my calculator, and what I'm going to do is I'm actually going to use the function that we have up here, x minus 1 over x squared minus 1. So I'm going to use alpha y equals to create a fraction. Okay, so alpha, and then the y equals button, hit enter. And I'm going to do x minus 1 on top, and on bottom, I'm going to do x squared minus 1. And I'm going to graph this. With what happens whenever you graph a function, okay, and you have a 0 on bottom at some point, okay, and you're typically kind of the mindset of what you've been taught is that when you get a and you look at the bottom, x squared minus 1, there are two things that can get equals 1 will give you an massive square. Yeah, so x equals negative 1 would also give you a 0 bottom. Now, if you look at my graph right now, and if you graph it in your calculator and you look at it, you can see that at negative 1 on this graph right here, when x is negative 1, at x equals negative 1. But at x equals 1, I mean, shouldn't something be going on at x equals 1 right over here, right? And look at the line. No ask in a 1, right? If you plug in a 1 into this problem, you'll see that you would get 0 over 0. And so this could be simplified. This limit right here could be simplified into x, and it was x squared minus 1. So you could change this into the limit as x approaches 1 of x minus 1 over, and that's a difference of squares. So you can do x minus 1 times x plus 1. And x minus 1s will cancel, right? And so what you get is the limit as x approaches 1 of 1 over x plus 1. And now when you plug in, you get 1/2. That's why this graph right here of this thing right here, if you were going on that line, would be at 1. What ends up happening there. However, in the other, so the now consider what would have happened to the exact same function, right? Let x approach negative 1. Well, at this point, when we let x a negative 2, and what are you going to get on bottom? 0. 2 over 0. And if you look at our graph, you can see coming at negative 1 from the left, you're going from the right, you're going to. But on the other hand, whenever we took the limit at 1, right? 0 over 0 is your clue that you can simplify and get a limit. A number over 0 of these. I want to skip. There's one of them that I want to skip in a little while, but this is not it. This is just going to require some factoring. It is x to the squared is 9 times 2 makes 18 right here in the front. And then the 5 times 3 is 15. And so the 15 and the negative 15 and the negative 3 will make negative 18. And that with a positive 18 you had in the front. Now, how do you simplify this? Does everybody? So what we can do on the top is we can break this into x squared minus 9 times x squared plus 9. Okay? It's very good to be able to recognize that that is two squares on top. That's key. On the bottom, what can we do on the bottom? Math magic. That's right. So we're going to break this into two sets of parentheses as well. But in order to get 2x squared, we're going to need a 2x and an x in those front. Then in the back, okay, two numbers that can 1, right? And one of them needs to be negative, one of them needs to be positive. But when we add, we need to get what right here? And put the negative 3 back here. And if I put the positive 1 right here, 6x, and this will give us positive 1x. And when we combine them, we'll get negative 5x, which is what we want, right? Take some practice, maybe even some trial and error for you to get really good at those if you don't remember doing those from Algebra 1. Like, absolutely. We can factor that right there again, because what is that? It's another difference of squares, right? It's another difference of squares. So this is the limit at x minus 3, x plus 3, times x squared plus 9, 2x plus 1, times x minus 3. That's all multiplication. So on top, the x minus 3 can cancel. Okay. Let me just come over here and see if I can plug in. So I'm going to take the 3 and plug it in. So that first one will be 3 plus 3 times 3 squared plus 9 all over 2 times 3 plus 1. Okay, so 3 plus 3 is going to give us 6. 3 squared here actually makes 9. 18 in that second spot. Now, what's is 108 divided by 7, right? One hundred eight divided by 7. For a limit to approach, right? So you're like, where's this one going to go? 108 over 7. But it's one of those things, when you start to simplify some of the different things that we're going to do, techniques that we use to simplify, you can get some pretty strange numbers, okay? So that can happen. And let everyone work this problem on their own. So with this one, really quickly, Avery wants me to tell Ceci hello. So, and Abigail. So hello to all the people who are not here from Avery. All right, so this thing will factor, and I don't need all this again. Let me just go ahead and factor it, right? The top part is going to, the bottom can't factor. There's nothing you can do there, but the top is going to factor into two sets of parentheses. And if Cameron so wisely x minus 2 in one of, your little parentheses there. So the other one would be x plus 3 in order to make everything work out on top. The x minus 2's do cancel. Then you can plug in the 2, and 2 plus 3 is 5. Right? So that one's nice and easy. Minus 1 times x plus 5x squared minus 6x, divided by x cubed plus 5x squared minus 6x. So if you plug 5 is 6, minus 6 gives you 0. So you are going to go over 0 in this one, which means that we can simplify. So the limit as x approaches 1, and then the top part is what? What is the top? Difference of squares. Very good. So this is just going to factor into x plus 1, x minus 1. Well, to factor the bottom, out an x on the bottom. So this will turn into x squared plus 5x minus 6. And now this stuff right here looks like a quadratic. Like a quadratic. So this will be the limit as x approaches 1. The top we can leave alone. And then the bottom is x times, and then this stuff I'm going to factor into two sets of parentheses. Since this is x squared, I know I'm going to use x and x. Add together, multiply them to get negative 6, add them to get positive, and a negative 1, because positive 6 plus negative 1 will give us a 5, and then the positive 6 times negative 1 will give us negative 6 whenever we multiply. So now that we've just 2, if we plug, we have 1 times, so this will be 1 times 1 plus 6, and 7 will be 7. So 2, 7.
You could get that without factoring out the really factor. It's a lot more difficult.
What do you mean? Like how would you?
I tried to do it like that, and then probably back to the problem, but I ended up getting 2 sevens. Like I did like x squared and then x on the beginning one.
Okay.
And then bunch of shit like that.
So you did x squared and x, and then what did you do on the next one?
I don't know. I traced it, but it's. I think I did like negative something. Six is negative one. Yeah. You go skip another step. Maybe.
Yeah, because what happens when you factor it out? I mean, it's whenever you have this thing right here. Let me take this. Okay, and so x times x plus 6 times x minus 1. Do you know the have these numbers? You can multiply them any you want to, right? So when there's a string, you can do the 3 times the 5 first and get 15 times 2, and you'll get 30. Or you can do the 3 times the 2 first and get 6 times 5 and get 30. Right? Or you can do the 2 times the 5 first and have 10 times 3 and get 30. Right? So the association that you can group any two of the numbers together first. And what you could do is you could group these two and multiply them together first and use the distributive property. And so you could get x squared plus 6x times x minus 1. So there's a way from the very start you could have factored it into something like that. And then if you did that and you had the x minus 1 on bottom, you could have gone ahead and canceled it out. And you can see if you plugged in your 1 into this, the x minus 1 would have canceled on bottom with that on top. Into this, it would be 1 plus 6, which is 7. It's mildly impressive, okay? Yeah, it's not that big of a deal, but still impressive in some regard. Well done. That one. I'm gonna do this one. Okay. Pretty good, Taylor. The 0 of 7x over x cubed. Plug in and yeah, very good. Take an x out on the top, and now this is x squared minus 7, right? So we just factor an x right out of the top. Take 1 out of x cubed, we get x squared all over x cubed. Yeah, I mean, you can take, there's one of them on top, which means I can cancel one of the ones on bottom. So instead of this being x cubed, now it's going to turn into x squared. Okay? So the limit as x approaches 0 of x squared minus 7 over x squared. Tell me about that. Because remember, whenever we do one of these and we get like a number over 0, we have to analyze. So it happens from need to analyze. And so I'm just going to try to think about this as the limit as x approaches 0 from the left for x squared minus 7 over x squared, and the limit as x approaches 0 from the right of x squared minus 7 over x squared. All right. Little bitty negative number, right? So if we plug it in up top, minus 7. So the minus 7 almost stays completely intact. On bottom, when we take this negative number and plug it in, what's going to happen? We're going to get we square it, it's going to turn into a positive number because a negative squared makes a positive. So on bottom, we have a very small positive number, and on top, that really is going to go away for the most part, and we just have good. Negative infinity. Number. So if we plug it in here, I mean, it's going to be something really, really little, and if we, a positive squared still makes a positive. So something really, really tiny, a bunch of zeros, and we're going to take that away from negative 7. Really not going to change the negative 7 by much, right? So we can just primarily the 7, that's what's in charge up there, okay? But on the bottom, and so the little number is just getting completely dominated. It doesn't even matter anymore, okay? But on bottom, the little number is all there is. And so we have to really pay attention to the little number. Little positive number and square it, and what's going to happen? A little bitty positive number. So a infinity, those two infinities match, and so we're just going to say the limit in general goes to negative infinity. Negative 2 right now, then you're going to have 1 over negative 2 plus 1 over 2 divided by negative 2 cubed plus 8. And these fractions, a negative 1/2 plus 1/2 actually makes a 0. And negative 2 cubed actually makes negative 8, so it is a 0. Which means we can factor. Absolutely. Well, here's what I would do, okay? When I have fractions, right, I don't like fractions within a fraction, okay? So if I have a fraction divided by another fraction, one, instead of having multiple levels to it. Well, that's exactly what I want to do with this. that, I have to turn the top into here, and I want to have 1 over x plus 1 over 2. And I take you back to 6th grade again for just a second. And let's say that we have 2/3 plus 1/4. Okay?
12.
Yeah, it's 12. Right? So do what with those two numbers? Multiply. And in this case, if you look, 3 times 4 actually gives you 12. Together to a calculus problem. Times 2. So 2/3 is the same thing as how many 12ths? Has already been multiplied by a 4. Multiplied this number by a 4. What should you do to that number? So I take this 4 and I multiply the number over here by it, and 4 times 2 gives me 8. I'm going to apply the same concept. I'm going to take this 2 and I'm going to multiply the opposite numerator by it, and it will give me 2. Now, same thing here. This 3 has already been multiplied into that 4, so I just need to take the 3 and multiply it by the 1 up top now. And 3 times 1 would give me 3. So I'm going to do the same thing here. I'm going to take this denominator and multiply it by that numerator. And x times 1 makes x. And then there was a plus sign in the middle all along, so I just keep a plus sign in the middle. Now, looking at this problem up here, what is 8 plus 3? And then I just write one denominator. So I actually add the two numbers together and just write one denominator. Well, how do you add 2 plus x? And then just like we added these together and wrote the same denominator, I've added those two together, but there's nothing I can simplify it to. And then I just put it over the same denominator. So 2 plus x over 2x, right? So it's the same process. Multiply the denominators together. There it is. This denominator times this numerator, there. This denominator times this numerator, there. And then whatever sign was in the middle. So this is the limit as x approaches negative 2 of 2 plus x divided by 2x. So there's the top part. And now I don't want a fraction within a fraction, right? So I'm going to write it horizontally. That is this stuff, this stuff up here is being divided by x cubed plus 8. So this is the limit as x approaches negative 2. And then remember, the way you divide by a fraction is to multiply by the reciprocal. This is over a 1 right now. put parentheses here. So we have the limit as x approaches negative 2 of 2 plus x over 2x times x cubed plus 8. You may notice that even now, if we put in a negative 2, it would still be 0. And the reason why I get it, okay? And so now we actually want to try to simplify this thing. And the only thing now, this is not a difference of squares. X cubed is equal to x cubed. I know that looks funny, right? But 8 is equal to what? 2 cubed. Very good. So this is actually a difference of cubes. There's a rule, and I have it back here, for the sum of cubes. The one on bottom. And we're only going to worry about it. We'll do the other one whenever we go through this again for AP. Cubed, not a cubed minus b cubed. Okay, so a don't worry, I'm going to bring it back. Yeah, sums is all we're worried about on this one. So this is going to be the limit as x approaches negative 2 of 2 plus x over 2x times. And then this thing right here is going to factor out. Now, what's my a in this case? Yeah, a is x, right, because it's x cubed. And b is 2 because it's 2 cubed, right? Okay, so it turns into a plus b. So that would be x plus 2. Exactly. In this case, minus a times b. Well, a is x, 2, so a times b is going to make 2x. Plus b squared. So b was the 2, so b squared is 4. The main thing I wanted to get across for you on this one was the fraction, okay, how to deal with that fraction. You're always going to need to change, you're going to need to combine the fractions and then multiply by a reciprocal to really get where you want to go. Now, this x plus 2 and the 2 plus x on the top, you know, I can just go up top and change this into x plus 2 and just switch the order if I want to, right? You know, a commutative property of addition, right? You can just switch them back and forth. And so these two things cancel. So I have the limit as x approaches negative 2. What do I do up top when this x plus 2 gets canceled out? Yeah, you got to put a 1, right, whenever you're working in a fraction like this. So this is times 2x times x squared minus 2x plus 4. And now I've actually canceled something out, right? And once I've actually canceled something out, I want to attempt to plug in again. So I'm going to do 1 over 2 times negative 2 times negative 2 squared minus 2 times negative 2 plus 4. Right? So I'm just going to take that negative 2 and plug it in now and see if I can actually get a result. So I have 1 over, I'm going to go ahead and multiply those together on the outside. That's negative 4 And then here is negative 2 squared, and that makes positive 4. Yeah, this right here is going to end up being plus 4. And then that right there is plus 4. So I have 1 over negative 4 times, and 4 plus 4 plus 4, 4 times 3 is 12. And so 1 over negative 4 times 12, negative 48. Sure. And make sure that the code's actually written on the inside of the textbook too. No. Just like, yeah, just put it somewhere in there. Yeah, that'd be fantastic. All right, so let's go to this one. Let's skip that one. Here's the one I want to get to, right? So here's the one that I want to get to. This video is going to be long for YouTube, so this will be the... Yeah. Yeah. I probably got about an hour right now. 7 hours? Apparently I'm not running out of time on YouTube. It's not like a Vine, huh? Just did Vines for the last... Let me off. All right, so you can see here that we want to plug in a 4, and if you plug in a 4 on the top, then, you know, this becomes 4 plus 5 is 9, and the square root of 9 is 3, so that's a 0, and a 4 on bottom would obviously give us a 0, so there's got to be some way we can factor. Now, the question is, who knows how? And this is when I like to torture you for a little while, okay? So, square it. Just square everything. No, she can ask that question, but here's the only thing. If you square everything, an equation, right? So you have like 4 equals 2 times 2, right? And so if you square everything, it's fine, because this will turn into 8, and 2 times 2 is 4. Oh, man. 16, right? And then if you square this, this turns into a 4 times 4, which would, you know, because I squared each of the 2's on the inside there, which is also 16. So everything still matches. So I'm perfectly fine, right? So that's okay. But if I don't have an equal sign involved, and let's just say I have some number like 3, and I say, hey, let's square it. So I square it. And so it becomes 3 squared. And now it's a 9. Is this still what it was before? No. So the only time you can do something like that, you know, squaring it, is if you have an equal sign and you're going to balance it out on both sides. Factoring, whenever you multiply it back together, and you know, you'll get back to the same spot. You change the value, you've just kind of reorganized. There are other things that you can do to an equation as well. Like, what can you do to a number and not change it? Multiply by 1. Good. What else can you do? What else can you do? Not quite. What did you say? Okay. There is one of them that involves 0. You can't multiply by 0, but what can you can add 0. So, if I had the number 3, right, and I add 1 and subtract 1, okay, what is this? 0. So this is really like this. So I haven't changed the value at all, have I? If I write 3 plus 1 minus 1, and you're like, incredible mathematical proof that hinge on that right there. Somebody adding other mathematical proofs that hinge on someone doing this. You'll see. It's going to help. It's a huge help. It's incredible help. Because what is 3 times 1? 3. But does 1 have to look like that? What could 1 look like? Good. It could also be what? 2 over 2. That's a what? It's 1. But now if you actually multiply that out, that makes 2 times 3 is 6 over 2. And now it looks completely different. But the value is, we started with a 3. The value, right? So you got this thing looking really different. But it has the same value because it's really clever. Okay? So I'll give you a clue. In order to factor this right here, you have very good, Melinda. That's it. Right? Because here's actually what you need to happen, right? You need for this square root in some way, in some respects, to disappear, right? So right now, remember we've multiplied by a difference of squares over and over and over again? So Avery was right. Avery's like, we got to square it. Can we get rid of this square root, right? So you got to square it somehow, but you have to do it legally. So you have to multiply. The problem squares, because with the difference of square, that's what this is. Because when you had x squared minus 9 earlier, you broke it into x minus 3, x plus 3, right? So it looks the same, except the back, the second number in the term now is like a big square root, but it's the same concept. 3 minus this stuff, 3 plus that exact same stuff. And what makes a difference of squares so unique, okay, when it comes to this, that when you actually have a difference of squares and you factored it down like this, so let's just say we're looking at this right here, and we're going to use FOIL method. The thing that makes a difference of squares so unique is this right here. You multiply, you get x squared. You get 3x. You get negative 3x, and you get minus 9. And here's what makes the difference of squares so valuable. These two numbers match, but they're opposites. Canceling out. And all you the first term squared and the second term squared. So imagine that with this. What you're going to end up with is the first term squared and the second term squared, but all this other junk that would have been in the middle is going to cancel out. It's behind multiplying in this way, right? It's called multiplying by the conjugate, okay? Multiplying by the conjugate. I'm going to work this one all the way out and just show you what happens, okay? And we'll kind of see the process of everything that it's going to go through. So let's start kind of working through this. All right, so I'm going to leave the limit as x approaches 4. And then, I'm going to have that in parentheses. And I'm actually going to FOIL this thing all the way out, okay? So 3 times 3 makes 9. 3 times the square root of x plus 5. Does anybody know what that makes? It's 3 square roots of x plus 5. Yeah, I want the square root of x plus 5 3 times. A negative square root of x plus 5 times 3. Well, a negative times a positive makes a negative, and it's 3 square roots of x plus 5. this. And now we have the negative square root of x plus 5 times square root of x plus 5. Notice it was a negative times a positive, so the result is going to be negative. And then the square root of x plus 5 times the square root of x plus 5 is going to make x plus 5, right? It's just going to come out of the square root. Notice I keep that negative sign, right? On bottom, okay, leave the bottom alone. Now, I want to make sure everybody understands. Have we changed the value of this function right here at all? No, because what do we... Crazy, but that is some number divided. Yet our problem looks completely different, right? Now, this and this will cancel because there's a positive 3 square roots of x plus 5 and then minus 3 square roots of x plus 5. So those things cancel, and so we have the limit as x approaches 4 of 9, and I'm going to go ahead and distribute. Minus x minus 5. Yes? Yeah, give me just a moment. Simplify on top, we have the limit as x approaches 4 of, negative 5 and positive 9. So this is negative x plus 4 all over x minus 4 times 3 plus the square root of x plus 5. Yeah, you can see what I want to factor here is the x plus 4 on top and the x minus 4 on bottom. The only problem is that the signs are mixed up, right? So what I'm going to do is exactly what 1. By factoring out a negative 1 on top, all it's going to do is change the signs. So the limit as x approaches 4, and if I take a negative 1 out, well, when I take a negative 1 out of negative x, it becomes positive x. Positive 4, it becomes negative 4. So by factoring out that negative 1, I got this thing where I want it. And now I can cancel the x minus 4 and the x minus 4. Now we're at a place where we want to attempt again because we just canceled something. So negative 1 over, and then on bottom we have 3 plus the square root of 4 plus 5. So that's negative 1 over 3 plus the square root of 9. So that's negative 1 over 3 plus 3, negative 1 6th. Let's do one more of those. Let's do, where's the one? Is there not? Let's just do this one. It's an easy one. Let me make this note, though. It doesn't matter if the square root is on the bottom or the top. You go through the exact same process. All right, so the limit as x approaches 7 of x plus 2 minus 3 over x minus 7. Because I'm going to take shortcuts. And if you want to remember how to do the shortcuts, you probably want one in your notes. can't take shortcuts the first time. I got to make sure you see why everything happens the way it does. All right, so the first thing that I need to do is I'm going to multiply by the conjugate. In this case, it is the square root of x plus 2 plus 3. So I have the limit as x approaches 7. Remember, the whole idea behind multiplying by the conjugate, you're using the difference of squares so that you and a last out. Okay? So you can go back and look at that example that we just did. The middle term canceled out so that you only get a first term and a last term. So in this case, I'm only gonna do a first term and a last term. Okay? So I'm gonna do the first terms times one another. And that'll just give me x plus 2 in this case, because the square root of x plus 2 times the square root of x plus 2, it just comes out of the square root. And then I'm going to multiply the last term. So a negative 3 times the positive 3 is going to give me negative 9. And then remember, leave whatever part didn't have the square root in it to start with. Leave the bottom alone in this case. If the square root was on the bottom, then we would leave the top alone. So the square root x minus 7 over x minus 7 times the square root of x plus 2 plus 3. And now the x minus 7s can go ahead and cancel. And that'll leave us with a 1 up top. And now we can plug in. And so if you plug the 7 in, you get 1 over the square root of 7 plus 2 plus 3. So that's 1 over the square root of 9 plus 3. And the square root of 9 is 3, so it's 1/6. All right, so your homework is page 94 in the textbook, numbers 5 through 23, the odd. So let me glance over those real quick and make sure I feel like you can do all of them. Okay, just do 5 through 21. We'll take 23 off. I'm in a generous mood. I'll take 23 off of there for you guys, right? So just do 5 through 21, the odd.